How's it going, everybody? Hanging out in the backyard here. Been a little missing in action here. I just want to give you a quick update of everything I've been working on and just ramble away for the next little while. To anyone new to the channel, my name is Kyle. I'd like to go out and do gold mining out in the wilderness and camping and stuff, but been a little bit busy just dealing with stuff here around the house. There's a little view here, but we're going to come into this shed, the dark and scary shed here, and this is the new home of my 3D printer. This guy used to be in a guest bedroom upstairs, and then we were sleeping in the bedroom right next to it, so it just makes noise all night, and I couldn't print all night. So now I can set something up in the evening. This was an 18-hour print, and this is a shell for an infinity jet that's fully adjustable. It's a 2-inch jet, but the biggest thing I've noticed when it comes to the efficiency, just close that ratty old contraption up. When it comes to the efficiency of a jet, I thought like a double jet would be better than a single jet, and an infinity jet would be the best of all. Turns out it's the size or the cross-sectional surface area of your jet matters the most. Which basically means you want the correct size jet for your pump. Now, I believe a typical 2-inch dredge has a 1/2-inch jet, and that's like with a gas pump, a lot of water, which is, I don't know, roughly 13 millimeters. Now, let me just set you up over here for a second. Forgive this is the little tripod I'm putting you on here. Set this up back here. Yeah, that should work out all right there. Make sure you're all level and good. There we go. So anyways, you get a big, powerful gas pump, and that 1/2-inch jet seems to be what you normally would get. I'm using a 15 millimeter jet just for this little electric pump, and that's the most efficient size. I tested a whole bunch of different jets, bigger ones, smaller ones, and 15 mil is what seems to work the best for this, because this produces the right balance of pressure and volume. That was the correct size. Now, if you use a 20 millimeter jet or a 10 millimeter jet, your suction goes way down. Like, you're okay in the range, 14, 15, 16 millimeters. It's all right. It peaks at 15 according to my tests, but you get away from that and your efficiency just drops. Now, I think one of the original things I read online, it was Gould Engineering. It was Reggie Gould did these tests where he found out that a triple jet was better than a single jet. He tested a suction nozzle, and he tested an infinity jet. And the infinity jet just blew everything out of the water, like way better efficiency. So I was like, cool, maybe I can, find some secret efficiency by using an infinity jet. And what I learned was that probably what happened is if you have a single 1/2-inch jet and another single 1/2-inch jet, and you go from a single jet to a double jet, you're not just having two jets, but you're increasing the total volume of water going in. If you had a single jet and you just made it bigger, instead of, you split that in half into two jets, you'd probably get the same suction. And that is what I found in my testing. If I have a single jet or a triple jet, if the size of the jet, the total surface area of that circle is the same, my suction is roughly the same. An advantage of a double jet is with a single jet, all the water is going to blast and sort of hit the opposite wall and potentially sandblast that and wear it away. Whereas with the double jet, they kind of meet in the middle and you won't get that sandblasting effect. And with an infinity jet, that would be the same idea. Yeah, I just thought that was interesting. I spent the last little while trying to design a gold dredge, but also learn how they work. And that was one of the most surprising things, is I could have sworn a double jet was more efficient than a single jet when it comes to like making suction happen, and it's just not the case. You need to size it correctly. So if we have a fully adjustable infinity jet, basically this screws inside there and you can screw it in and out. So as you screw this in a full rotation, it moves 2 millimeters closer, which narrows the gap or increases the gap. And then you, with whatever pump you have, a lot of guys out there don't have an expensive gold dredging pump, which is a higher pressure pump. you're dealing with just a transfer pump or a trash pump of some kind you get from Harbor Freight, Princess Auto. These are designed to move a large volume of water, but at less head pressure. And so you're better off with a larger diameter jet than a standard dredge. So you get a 3-inch dredge or a 2-inch dredge, and it has whatever, a 3/4 inch nozzle or a 1/2 inch nozzle. You might be better off with a much larger nozzle to match your pump than you might expect. And so to harness that, if you had an adjustable jet, that would be great. This is an oversized suction jet, so the inside diameter of your hose, the hose fits inside of this, so it actually plugs into this, and then you can unscrew that. This guy plugs over that end like that, and on the opposite end, it plugs into that, and all goes together. But your hose comes in here. This is all plastic. Now, plastic comes in different qualities. I think your hose is made out of plastic, and it doesn't seem to wear out, so long as there isn't like a lip that this is going to hit when it inserts and it just flows right through the middle, I think this will last quite a long time if I print it out of like a good technical plastic. Like, this is ABS, high impact, good stuff, and ASA is what I'm thinking of testing for like a production model, which is basically a completely UV stable. You can leave it out in the sun for a year and it doesn't get all brittle and crappy, and it's good temperature resistance and all that stuff. This is a clear PETG, just so I can shine a light through it and show you in the following YouTube video. But if I produced something where you could take whatever hose and just stick it into this hole, tape it into place or glue it on, and now you've got a quick connect where you just stick that into that, screw it on, you're good to go. That would be very useful for a lot of people who have just like a random pump and you want to match the size of your jet to your pump perfectly. Well, you just screw this in and out until you maximize your suction, put a little marker on it with a Sharpie. If it ever gets dirty, you unscrew it, clean it all out, screw it back up till you get to that point, and it's probably a really good solution. It'd be lighter than metal. I'm assuming it would, like real world conditions, probably be about as durable. The one I'm printing down there, that 18-hour print, is quite thick. So think like the ABS pipe fittings you get for plumbing stuff, and a lot of guys use those that like modified to try to make their own jets. And if you could just 3D print something that's like as efficient as possible, made out of a plastic very similar to that, or slightly better than that, if that's what they claim ASA to be, could be something. If I was in the market, I'd want to try one out. So I'll probably mid to late August be able to launch that product with a little better video and talk about how it works. And I'll show you. I've got this to test the flow. There's basically a little propeller in here and a Hall sensor, and you plug it in and it lets you know how things are going. So I can compare side to side and sort of see how we're doing for suction. This is what I've come up with as far as a 2-inch dredge. And you've basically got a suction nozzle, which means that it primes very easily if you're in shallow water, which is what you would be doing here. And by the time it gets to the sluice box, it doesn't blast all of your gold out the back. This hose is a 60mm hose, which is 2 3/8 of an inch. And this piece goes inside the hose, which is not ideal. I like the way this is gonna let the hose insert, so it's not like a place for rock jams to happen. But just for now, this is what I've got. I'm experimenting with it. This just slips right in like that and locks into place, and then you press this in, thread it on. I might use a coarser thread for the production model of this, just to make sure it's easy to get started there. There we go. Or in the 3D printing process, you can kind of taper the tip of the threads, and I'm learning as I go along here. But this is a Pelican case. It's a size 1200, and inside this case, we open this up. You've got an 18-volt tool battery. If people have these lying around, you can get all the electronics that steps this down to 12 volts. Then you've got this little switch here, and I don't know if you'll hear it. I'll get my mic up here. Yeah, so this floats right around the line of the seam here with a 12 amp hour battery in this box, which would run this for an hour and a half. If you were to just get a lithium iron phosphate, so it's LiFePO4, you can get these on Amazon or eBay. 30 amp hours or 50 amp hour size, get a box that fits that battery, and then the box that holds the battery and the electronics and the switch is also a float. So this floats on this side, right at about the height of my hand is where the water is. This supports some of its own weight because it's in the water. And then on this side here, we just have a float. So this keeps it stable left and right. So you don't have to worry about having a rounded bottom of your sluice that can tip like a typical, you know, one of those suction tube underwater things. And then, yeah, you've got your suction nozzle over here. You fire it up, suck all your gold, and it shoots out the back, which brings us to the next part. To anyone new here, this is the stock impeller for this pump. It's an open-faced 3-blade. This is an open-faced 6-blade, and this is a face that I've glued to the front of it. So water likes to go from this tip back to the inside and sort of circle around, and it's a point of inefficiency. So by putting this face over it and sealing it up nicely in there with the same electrical use, so it's about 185 watts with the stock impeller and about 185 watts with my impeller, but I'm getting 25% better output through that jet just with a change of the impeller. So it's free efficiency, pretty cool. This is just horribly printed. This was wet filament, PETG, needs to be dried out. So I dried it out and it was still not super good. This was the stock settings on the Bamboo Lab printer, and it just doesn't like the Bamboo Labs filament, the PETG basic. And maybe blue is a problem, I don't know, but it wasn't pretty. So I switched some settings and made it print slower, and we actually got a good print out of it. But this is one of the things that takes a bunch of time. I only have so much time to devote right now to this project and this channel, and yeah, annoying, but now we've got it dialed. And the way this works is there's a little lip at the front here. So if we take this Dream Mat mini mat, we can slide it up here and it'll just plug in under the front there. So from this angle, it's very smooth. It just comes right on top of the mat, gets working. This guy can plug in there, and then it all plugs in here. And I could either get like a water bottle holder on each side back here and just have a couple water bottles that you know, hold it at this height, or print in some flotation. I'm not really sure what the best approach is, but this will hold it at the correct angle this way, and that keeps it from tipping side to side. And you got your suction there, and it's something you could, it all screws apart, and you can throw it in a backpack and hike into the middle of nowhere with a wetsuit and everything. It would just be the ultimate compact, quiet way to actually dredge some pretty cool places. But excuse me. This is how far I've gotten so far. As far as turning this into a product, because it's like, here's, you know, I'm playing around with this on YouTube and I'm learning about it, but this is a solution to a problem. And there's people who would want this, like, man, that's awesome. So I'm working on it. It would be really awesome to just have, like, here's a box, everything's in it, including the bilge pump with your impeller already installed, maybe a spare impeller in there since we're shipping it anyways. This Pelican case, I mean, these are not cheap, but, you know, I could get the switches and do everything, but I need to test this stuff first. I don't like the idea of like selling prototypes for money that aren't that good yet. The nozzle, for example, it's available for free on my website just as a print file. But this Infinity Jet, I could use a little cash. So I'm thinking if I can make this and it's a good plastic, and it might be like with all the fittings and everything, this could be like $40 of just plastic. And then however long, a little over 24 hours to print everything. But if I can make a product like that and still make it semi-affordable and like available for sale, then the Australian subsidiary of Utmost Outdoors, Carol, could essentially, you know, be the business behind everything, and my Canadian company, Utmost Outdoors, could actually sell a product, and I could make a little bit of money on the side, which would be pretty cool. And I think that would actually be a really useful, like, if this existed on the internet, I would buy it. I would be like, I need that, give it now. So that would be kind of cool if that works out. And this mat right here, this is the next stage of this process as I, you know, refine the battery box and everything here. I want to work on mats, and a mat that can capture gold subsurface probably runs along the same principles as a surface sluice box. So just to be back to basics here, Surface sluice box, you have this, it sits at an angle, say it's 1 inch per foot or whatever that is, and water flows over the surface at a certain velocity, washes material away, and the heavier material stays behind. And different riffles have different shapes. This is sort of running little circles like this. This is called Dream Mat Mini Mat. Apparently it works really good here in Australia at separating out like the heavy tins and black sands and stuff. I've used some, I don't know, a whole bunch of different types of mats, but the gold that's a little coarser in BC, like it's still fine gold, but it's not pounded into these flat airplane flakes like the Alberta stuff. It doesn't take a lot to catch it. You find it in the top of your sluice. You can have a very high energy sluice and it just works well. The fine gold beach box style of box is where you have a really low energy, low profile mat like one of these. And so I've got a little bit of a cold here, but you basically match your mat to your water flow. So if you have very small features on the mat, you want very small water flow over that mat. And with small water flow, you can't process a lot of material. If you just dump a full shovel on, it just sort of covers the whole mat in material and it's not active anymore. So you need a wider mat to keep up with you. With a subsurface box, we have to have a narrower sluice than we would otherwise want, because we have to have a taller sluice to make sure that rocks don't plug up in it. So if this is a 2-inch dredge, we need this to be at least 2 inches tall, which means that it has to be narrower to have enough velocity to actually keep everything here working. If we went to a surface sluice box, say 12 inches wide, lift it up as low as we can, keep it right down close to the water, but lift it up a little bit, I think we lose about 20 to 30% of our suction, which is still functional. Like this will still suck gravel through it and work with a surface box. But then we're adding floats because we got to hold the whole thing up on the surface. And those floats, whether they're inflatable or whatever, they're going to add weight to this whole thing. This is ridiculously compact. This would all literally fit inside a backpack. So if I can get this to work, unless you have really loose sandy material with nothing but fine gold, most places you're mining, you're going to have, you know, gold that we should be able to catch pretty easily in a sluice box. And if we can do it in something this compact, then we're staying with that theme of light, compact, electric dredge you can take anywhere. So I want to work on this a little bit better. When it comes to mats, this is another upcoming project of mine, is I don't want to get into the politics of whose mat is better and selling different mats and stuff like that. So anything that I design as far as a mat, I want to make open source, whether it's a free file on my website or however it is. I think of everything that I want to do to sell to make money. I'm not going to do that with mats because I want to do a unbiased test where I test a dream mat versus a gold hog versus a, you know, miner's moss and all this stuff in different situations. And I don't want at the end of that to be like, well, he's just trying to sell his mat. So speaking of how mats are produced, a gold hog, which I don't have one here, it is extruded. So you have a 6-inch long section of mat that is 36 inches wide. And you take that mat, and if you want a 6-inch wide mat, you cut it into a bunch of 6-inch sections and you plug them in lengthwise. And with that production method, you're able to get the profile where it sort of like goes and hooks back and then goes and hooks back and have like little undercuts and all of that kind of stuff because it extrudes out sideways. However, with something like this dream mat, you make this mold and you get your polyurethane and you vacuum all the air bubbles out and you pour it into this thing and then it sits there and then you peel it out and you get this mat. So when you have to release it from the mold, you can't have little hooks that overhang, which is why all the features here are vertical, like straight up and down. The mat I sort of settled in back in Alberta, it's called Devon Gold's VDR Infinity Mat or something, or I'm not sure if there's an infinity in there, but it's the same idea where it's in a mold and it peels out. And the advantage of that is you can have linear separation. So with this, you've got, separate cells. So if this tips a little bit in a sluice box, you don't get everything just sliding to one side or sliding back to this side. With the VDR mat, it's sort of has some drop riffles like this, but they don't have these linear dividers. And with the method of production like this, they could add these and it would still work and they could still peel their mat out. And then they've got these little circles that go across, and the circles are not prone to that side-to-side tipping, because once you're into one circle, you won't hop over into the next circle. But I had made the suggestion that if you separated the mat into a bunch of like 2-inch wide pieces, or here I've got little 1-inch wide pieces, if your sluice tips very slightly, like on a gold dredge it might, or in a small scale shovel-in high banker operation, this is designed to be full of a certain amount of black sand. And when more black sand gets added, it scours out and just concentrates the gold in what's left. But if you tip it to one side a little bit, all of the material goes to this side. And now it's got twice as much material as it needs, and it starts scouring that out down this edge. And when you scour out that black sand, you lose that ultrafine powder gold. So by having separate linear separations down a box, I think for a production field machine, that would be a big advantage. Also, I did a test on the VDR stuff. Drop riffles are great. And I basically took a snuffer and took all the gold out of the drop riffles and then took it all out of the little circle things. And I think way back in the day, somebody just like had a machine and sort of like machined down into a piece of aluminum this little circle thing, and it captured gold. So that's like the cool patented feature of that mat. But those circles don't work as good as the drop riffles. The drop riffles in 2 different tests, both had like, I don't know, at least 60% of the gold. I didn't weigh it, but it was like clearly the drop riffles were doing a better job than the little circles. So if you were to take those drop riffles and then just give them the linear divisions, and then the other thing with the drop riffle is there's a ratio of like how deep is it, like, or how long is it versus how deep it is. And the VDR stuff's about 60%. If you make it shallower, you're going to get less black sand. So it's going to be better as a cleanup sluice. But if you make it deeper, you have the potential, you have a surge going through the sluice box. There's more black sand in the bottom to protect your gold as a bit of a cushion. And I think for field production, you'd want a deeper profile at the risk of, if you're using it as a cleanup sluice, you'd be like, well, it has all this extra concentrates. So you got to find that balance. But I'm the kind of guy, I would much rather have miner's moss with expanded. Expanded keeps that left and right thing dealt with. The miner's moss, it's just like this random sort of lattice profile. You add more energy, or a rock rolls over the surface and material like water sort of goes underneath that rock and pushes down into the mat. It just jiggles everything deeper into the miner's moss. And then you have a little less energy. You don't run material for a while. You're working up near the surface of the moss. So it has that flex, and the disadvantage is more material. But so long as you want to come home at the end of the day with the most gold, that's sort of my real world use case choice. But I'm curious, can we make a mat that does as best as it can to, deal with those real world situations by making the drop riffles slightly deeper at the expense of more concentrates? Does that then start to compete with this? If you look at the manufacturing method, with 3D printing, we can take advantage of putting linear lines down it and have little hooks going over, so you can combine the extrusion method of Gold Hog with the sort of mold method where you have linear things going on. And that would be really interesting with a 3D printer. But if you wanted to make something where it was a mold, you couldn't do both, because then you wouldn't be able to use it as a negative and a mold, or you'd never be able to peel your piece of rubber out. But then you could print it with like the rubber filament, and who knows where this goes. But I'd like to experiment with this at some point, because it is kind of cool to think about. It's just, as far as whatever design I come up with, even if it's amazing, it's free. It'll be available. I don't want to get involved in trying to, be a salesperson for a mat, because I got better things to do than that. But yeah, mats are interesting. Basically, you got to size this sluice. I think this needs to be a little narrower. I don't think it's going to have enough energy to activate the riffles as a 6-inch wide sluice. But we will see. And yeah, Infinity Jet mats. Here's the 2-inch dredge. I think the Infinity Jet could definitely be made as a 3-inch. I'm not sure I could fit a 4-inch into my printer, but the new one is more compact than the one you see here. Like, I've already tightened it up. I spent like 2 days modeling after that was already built, just to dial it in a little bit. So we'll see. And hopefully at some point mid to late August, you'll be able to buy one of these Infinity Jets. Let me know, either just in the comments or by email, like, how interested are you in this? Do you want a 3-inch version? Should I put the effort in? I'm kind of just when I have the spare time, this is what I'm working on. And coming up, my utmost adventurer high banker, I am going to actually shovel into that in 2 weeks' time. So I'm going to fly out, and it's in the southern hemisphere somewhere, and we're going to see how it captures fine gold here in the southern hemisphere. So that's a 1 week gold mining adventure trip where I'll actually get out and go camping and do a whole bunch of cool stuff, and I can show you all of the fun adventures here on YouTube. And yeah, so that'll be interesting. Till then, keep on being awesome, and thanks for listening to me ramble for the last however long this has been. Cheers, guys.